Hello everyone! So today we are going to take a look at the Part 2 questions for Test 2, starting with number 25. So 25 says to transform the equation x minus 3y equals negative 15 to express it in slope-intercept form. So I'm hoping that you're thinking about what slope-intercept form means. And when we see this, or whenever we talk about the equation of a line, we must be thinking of y equals mx plus b. Remember, we call this slope-intercept form because in this form we can come up with the slope and the y-intercept. So this question is just asking for you to get it into this form, which means you are going to take the equation you have here and get it so that way y is by itself. So you need to get this y by itself. So I would rewrite your equation, use your inverse operations, and then isolate the y variable, and then you are done. Please don't forget that we never circle our answers for Part 2. Go ahead. Number 26. Describe the range of a square root function. So range, remember that range means your y values, and we are talking about a square root function here. So you should be thinking of your parent square root function, which states y equals the square root of x. What I would do for this one is if you're not sure about what your y values could be, which also stands for your outputs, you could put your parent function into your y equals in your calculator, and I would take a look at your range of values, your y values, and see how can you describe all of the y values that you see there. You should be able to describe the range. You could do it in words. You could describe the range using an inequality with the letter y. Okay, so go ahead. Number 27, factor completely. We've seen this one before, so factor completely, remember, that means that you will factor more than once, always. So you need to go through your methods and ask yourself, in order, is there a GCF? If the answer is yes, you will do that. And then ask yourself, can I do the AC method? Or can I do dots? So I'll start you off here. When I ask myself if there is a GCF in this trinomial, there is, and it is just a number, and in this case, it is the number 2. So I'm going to take out a 2 and think of backwards distributing. 2 times what would give me 6x squared? That's 3x squared. 2 times what will give me back negative 4x? That's negative 2x. And 2 times what would give me negative 2? And that's going to be negative 1. Okay, so far we've factored once. We just used the GCF method. Now I'd like you to take a look at what you have inside your parentheses and ask yourself, can I do this AC method or can I do dots? I hope you see which one it is, so go ahead and do that method with what is inside the parentheses very carefully. When you are done, do not forget to bring down this 2 at the end. So you should be bringing it down. In the end, your answer should look something like this. And then stop there because all this question is asking for you to do is to factor. Go ahead. Number 28. Sales in the printing business have doubled for James in each of the last 3 months. During the last month, he made a profit of $520. If the pattern continues, what will be his 3-month total profit at the end of the next 3 months? So they told us an awful lot here, but let's just map it out. So the business is doubling in each of the last 3 months. During his last month, he made a profit of $520. Okay, so that's where he left off with. It says, if the pattern continues, what will be his 3-month total profit at the end of the next 3 months? So what you need to do is find out how much will he make next month, the next month, and the next month. And you should be following the same pattern for how you get from one month to the next. So this should be for the next month, the following month, and then the next following month. Okay? Remember, every time you read a question, please don't stop when you're done with your work. Reread it and make sure you're answering the question that is being asked. So once you find your next 3 months using the pattern that was up here, the question is asking for his 3-month total profit. So here are his 3 months. They are asking for the total of the 3-month profit. Please be sure to write out what you are doing to get the total profit. We must remember to always show all of our work. Go ahead. Number 29, find the sum. We have 2 fractions here and express it in simplest form. This is actually a topic that comes from the 8th grade curriculum. However, we do need to just follow our fraction rules. So remember that sum says really means to add them. So that means I'm going to write 3b over b plus 2 plus 12 over b plus 2. Okay? Think back to your fraction rules, and when adding fractions, your denominators need to be the same. They are. Both of them are b plus 2, which means I can just go straight to my numerators and add them up. Notice they are not like terms. So we just have 3b plus 12. And then we keep our denominator. So when the denominator is the same and we're adding or subtracting, we just keep it. And it does say in simplest form. So what I'm going to do is check to see if I could simplify anything. And I could factor this numerator by using GCF. So if I take out a 3, I'm left with b plus 4 all over b plus 2. So again, this was an old topic that we didn't get to see this year, but that's okay. We're just following our fraction rules. And it is in simplest form. We're not able to simplify or reduce anything. So then what I have here is our final answer. And that's it. Number 30 says to find the area of a rectangle with a length of x squared minus 2 and a width of 2x squared minus x plus 2. So if I am finding the area of a rectangle, I'm going to write down my area formula that I need to know for a rectangle. And I'm just going to plug in those pieces that they gave me. So it said that the length was x squared minus 2, so I'm going to plug that in for the length. And I'll always use parentheses whenever I'm plugging in a polynomial. The width, they said, was this, so I'm going to take that here and plug that in for the width. Since I am multiplying, I never like to put a dot in between 2 parentheses. I just put them right next to each other. So 2x squared minus x plus 2. I hope at this point you see what you need to do to find the area. That is either double distributing or making your box for the box method. Please be sure to combine any like terms in the end. Be careful. And then once you've done all of that, you are finished and you found the area. So remember, when we are multiplying, we multiply the coefficients. We keep the base, which is our variable, and then we add the exponents. All right, go ahead. Number 31. All right, so we are given a function rule here, and it says to find h of negative 2. So they are replacing the x with negative 2. So that simply means that I'm going to replace negative 2 everywhere I see x in this function. It is so important for this one that you make sure you plug in negative 2 in parentheses everywhere you see x. So it should look something like this. Okay, wherever I see x, I'm being sure to plug in negative 2 in parentheses. Now you need to evaluate this. Please follow your rules of PEMDAS, which means you should be doing this first. Rewrite it. Only do one step at a time. Don't do too much. And then go all the way until the end, until you have found your output. Go ahead. Number 32. Rows of chairs are set out for a wedding. There are 6 chairs in the first row, 4 chairs in the second, and 22 chairs in the third. The rows continue in the same pattern for a total of 7 rows. How many chairs are set out for the wedding guests? Well, let's see. The first row has 6. The second row has 14. The third has 22. They said that there was a pattern, so I do want to look for a pattern here. This is the third row. And I will stop when I get to a total of 7 rows. So this is the fourth, the fifth, the sixth, and then the 7th row. So it's up to you to figure out what is the pattern. How are we getting from 6 to 14 and 14 to 22? Notice that pattern. Find out how many people are in the 7th row. And then the question asks, how many chairs are set out for the wedding guests? So that implies that you need to find the total amount of chairs. Be sure to show your work so your scorer knows exactly how you're finding that amount. Go ahead. 33. Jennifer and Kim enjoy making bracelets. At the beginning of this year, Jennifer had already made 25 bracelets. She continues to make 8 bracelets every month. Kim just started making bracelets recently, so she had only made 11 at the beginning of the year. Kim is able to work more quickly, so she makes 10 more bracelets every month. Now, I just read that, and it seems like an awful lot, but we're going to go back and take it apart. Okay? So question A says, write an inequality. I want to make sure I'm using one of my inequality symbols to model the situation comparing Jennifer and Kim. So if I think about this, Jennifer already has 25, and she's making 8 every month. So let's see. Jennifer, she has 25, and she's going to continue making 8 every month. I'll use M for month. Meanwhile, Kim just started, so she had only made 11, but she works more quickly, so she's going to make, in addition to that, 10 more every month. Okay, so these are my two expressions. This side we have Jennifer, or Jen, and this side we have Kim. The question did ask for an inequality, so I do need to think about what symbol I'm going to use. And when I read this, I noticed that Kim is making more per month, so eventually Kim will be greater than Jennifer. Okay? Question B says, during what month this year will Kim have made more bracelets than Jennifer? So, what it's up to you is you need to solve this inequality for M. Use your properties of equality. Get M by itself. Remember, when you're working with inequalities, if you ever divide or multiply by a negative, you must flip the sign. Don't forget about that. And it's asking for during what month will Kim have made more bracelets than Jennifer. When you solve for M, that's going to tell you how many months it will take for Kim to make more. And however many months it takes, you need to figure out whether that is representing January, February, March, April, and so on. So you need to figure out what month that represents. Try your best. Go ahead. Number 34. Create a scatter plot to demonstrate the relationship between the snowstorms this year and the average amount of salt used on the roads in town. Whew. All right. I'm going to use my calculator whenever it mentions scatter plot or line of best fit. So have your calculator ready to go for this one. Just pulling it up here. Okay. It says sketch a line or curve of best fit. So let's plot our data first. Okay. We have our data here. Remember, these are always your x values and these are your y. I notice my x has to go up to 5. So instead of scrunching them all and going by ones, I'm going to skip every 2 boxes and then number it, just so I can stretch my graph out as much as I can. You always want to use as much of the space as possible. So this is your snowstorm. We always want to label our axes. And on our y-axis, we will have the salt in pounds. And I notice that I will need to go up to 15. Okay, so I want to work that out as best as I can, seeing what I should count by. And I'm going to guess I'll probably have to count by ones. So this will be 1, 2, 3, and so on. Keep going, please, until you get to 15. Then you're going to plot your points. Okay. Depending on how the data fits, you'll probably want to make, since it says a line or a curve, I would always go with a line and connect them. making one line going through as many points as you can, kind of like the line that's going through the middle of the points. And then what you're going to do is for B, it says determine a function to define it. If you made a line, then you need to use your slope-intercept form, and you need to use your calculator to actually come up with that for you. So I'm just going to remind you how we do this. And if you go to Stat and enter in your data, okay, sorry, I just need to go back and forth here and see what I'm inputting. So 1 through 5 is on the left. And then we need to input our corresponding y values, so 3, 4, 8, 10, 15. Okay, and to find the line of best fit, these are the steps that you need to know. So we're going to hit the Stat button once all our data is in. I want to calculate something, so I'm going over to Calc. And remember, we used to use option 4, linreg. Remember, the line of best fit is also called a linear regression. So if you hit enter and hit it until the data comes up, they are giving you here your linear equation. And in this case, A is taking the place of M, so you're going to plug in 3 there. And then you'll plug in -1 for B. And that's it. You have your equation of your line of best fit. So when they say determine a function, to define it, that's this. You need to come up with your function rule. Go ahead. Number 35, sketch the graph of the given data on the accompanying coordinate plane. Choose and state an appropriate scale so that all the points can be plotted. So if I look at my x values, I just need to go to 4. So again, I'm going to skip every other box just to stretch out my graph. Okay, we know the origin is here. This is 0. And my y values need to go up to 81. So you need to think about how to best fit all of those data points. And it seems like counting by tens might be the best way to go. Let's see, 10, 20, 30, 40, 50, 60, 70, 80, and then 90. So that is perfect. I would count by tens. You're going to plot your points, and it says write a function rule. So for this one, I hope you notice when you plot your points what sort of function it makes. And remember, we can always analyze our output values to help us come up with the function rule. I hope you see a pattern of multiplying by 3. You should be thinking of what function models this, and that function is an exponential function when it is multiplying. You can use your geometric sequence to help you come up with this, or it's always going to be y equals, and when we go like this, A is what you're going to plug in for your first value, and B is taking the place of your constant ratio, the number that you are multiplying by over and over and over, and that is your function rule. Go ahead. Number 36, the data chart to the right represents the local baseball team's shoe order. Write the linear regression equation for the line of best fit for the data in the chart. So we actually just did this for the other question. So what you need to do is go to your Stat, edit, and enter this data in very carefully into L1 and L2. You're going to find the linear regression, which means you need to come up with the y equals mx plus b. Remember, the calculator uses the letter A for m, and it uses b for b. And you're going to round the numbers to the nearest hundredth. So I bet when you input this data and find your linear regression, you're going to have very long decimals. Okay, so nearest hundredth, you should have 2 decimal places for your m and 2 decimal places for your b. Go ahead. B is asking for the correlation coefficient. This was that small letter r, lowercase r, that you saw on your calculator when you did your linear regression. So I'm just pulling up mine from earlier. The small letter r is right here. That stands for correlation coefficient. If your R is not popping up right now, that means your diagnostics is not on. So if you did not get that small r, please follow along with me. You're going to hit the second button and then 0 to get to your catalog. You want to scroll all the way down until you get to diagnostic on. Okay, and then you're going to hit enter. And then you're going to hit enter again and your diagnostic is on. Once it's on, if you go back to how you found the linear regression before, option 4, and hit enter, now that R value should pop up. So go ahead if you weren't getting that before. And letter C, determine if the correlation is good and explain why or why not. Remember that correlation just stands for a relationship. You tell if a correlation is good or not if the R value is very close to 1 or -1, that means it's a strong relationship. It is good. If it's not very close to 1 or -1, like it's close to 0, that means it's a bad relationship. Those variables were not connected very well. So you want to say whether it's good or not and tell your, write on your paper why you came to that conclusion. Go ahead. All right, last one, number 37. Jonathan makes a weekly allowance of $25. He also makes $9.50 an hour at his job. Because of his age, Jonathan can work no more than 20 hours a week. Letter A. Write a function for the amount of money he makes each week based on the amount of hours H that he works. So, they're telling me to use the letter H. So I would normally write f of x, but they want me to use the letter h for my input. So let's see. He does make $25 every week, and he's going to make $9.50 per hour. So that just means multiply by hour. Okay, so there's your function for that. B asks for the domain of the function. So remember, domain is your x values, your inputs. In this case, we're not using the letter x, we're using h. So I want you to think of what are the only types of numbers that we are allowed to plug in for h. Can we plug in any number we want, or are we limited? So you're going to write h and then write some sort of inequality that represents the domain. Does h have to be greater than a number, less than, equal to? And that is what I'd like you to think of. Keep in mind up here, okay, they mentioned that he may work no more than 20 hours a week. So you should actually have some sort of compound inequality where h is in the middle, and you have some inequality sign here, and some sign here, and then some number, and then some number. So think carefully about that. Go ahead. And then letter C. Sketch the graph of the function you chose over the domain that you chose. Okay, so you make sure you only go from your values that you used in letter B. Stories, remember, always occur in the first quadrant, okay, which is that one. So you should only be making your graph in that section there. You want to make sure that you choose a scale that'll fit your domain. So think about what the highest number is that you want to make sure you get up to. And then you can go ahead and start plotting and think about your y-axis as well. What do you want these values to be able to go up to? You will come up with your y-axis scale by thinking of what's the most amount of hours Jonathan could make, and how much money would he make if he worked that most amount of hours, which is actually 20. And that's the highest number you want to reach on your y-axis. So we have a couple choices we need to make here and need to think very carefully. Okay, that is it for part 2 of test 2. So thank you so much for watching this video. I hope it helped, and I will see you in class. Thank you.